Good morning, everybody. Welcome back to lecture number 16. Forgot how to count. Well, lecture 15 is gone, so this is lecture 16, okay? This is lecture 16. Today, we will start by the checkpoints of chapter 3 that you really need to study them in the quiz. You really need to study them in the quiz. You really need to study them in the quiz, okay? You have a circuit at time 0. You have a current source of 2 milliamp, a short circuit, and a capacitor of 10 micro. What will happen if I have a short circuit? All the current will go through the short circuit and come back, regardless of whatever is connected to it. At a certain time, I open this short circuit via a breaker. If I open it, it's like erasing it. So think of this circuit as a current source and a capacitor. So it will be, not a battery, it will be charging. And to write the equation, I have to pull up my phone because I cannot memorize it. So, what is I of 0? IC. Current IC at time 0. Well, is it 2 Yes. Just before I close the switch, capacitor needs to charge. Capacitor needs to charge. So the current at time 0 is 0 amp. Get it? No, not the current, the initial voltage. My bad. The current will be 2 amp. What is the voltage across the capacitor at time 0? The question is, find the capacitor voltage at time 10. So we need to find the time expression and then plot 10. So at time equals 0, the initial voltage is 0 volts. Then what's the equation of V of C? It's 1 over C, integral from 0 of t, I of t, dt, plus Vc of 0. You remember this equation? So what is the current? So that it will be 1 over 10 micro, the integral from 0 to t of 2 milli, which is 2 times 10 to minus 3 dt. So the final answer will be 200 t. Get it? It will be 200 t. It's a constant. So at time, at t equal 10, what's the voltage? What is Vc of 10? No, 10 milliseconds. Milli, which is 200 times 10 to minus 3. It will be what? 2 volts. Get it?
Yes.
What is the power? Passive sign configuration. Did we have a negative passive sign configuration in the test? No, صح? The major. Maybe one question, the elements question, صح? So what is the power? VI plus, because the current enters from the positive. So when I close the switch, the whole 2 milliamp will go through the capacitor. The voltage will keep charging over time. So what is the power? Power is 2 times 2 milli, which is 4 milliwatt. What is the energy? It's half CV squared, which is half times 10 micro times 4. This is all at time what? 10 milliseconds. The final answer will be 20 millijoule. If I bring you this question in the quiz, will you be able to solve it?
Sure.
Get it? Another checkpoint.
So why millijoule? Shouldn't it be microjoule?
Well, that's wrong. What is well, it is half. What is C? 10
Microfarad.
times 10 to minus 6. What is V squared?
240.
2 squared.
No. The equation is half CV squared. So what is,
We get V as 2.
well, write it as a function of t. So it will be t squared, okay? Half CV, what is it? What's the equation of V? 200t. T all square, okay? I didn't bring my calculator. في أحد معه calculator?
But shouldn't
Equals what? Half times 10 micro is 10 to minus 5. 200 times 10 million. All square. I think it's 20 millijoule.
there shouldn't be any difference if we substitute.
Okay, what's the final answer? 20?
10 to the power minus 6.
There's something missing. Did you put 10 milli?
Yes.
Yes. 20 times 10 to the negative 6.
What's the answer?
20 times 10 to the minus.
Doctor, maybe we need to do derivative.
No, that's the right expression. Half CV squared. This is the time expression, 200t. Half times 10 micro times 200 times 10 milli. Well, I guess it's 2 times 10 to minus 5
I
joule.
think it's 2000 T, not 200.
1 over 10 micro times 2 milli. No, that's 200t.
200?
Yeah. I think that's the right answer, sir.
Yeah, I think.
2 to the minus 5
Yes, yes,
joule,
I think.
which is 20 micro.
Yeah,
Yes.
yes.
That's
Get it? Thank you for capturing the mistake. That was a mistake in the solution manual. So never trust the solution manual. The other question is very similar. The other checkpoint, which is where? This checkpoint, okay? A constant voltage of 20 volts is applied to a 10 microhenry inductance. At what time Tx does the current reaches 200 milli? So we know the voltage is applicable to, is applied to the inductor. So we have to calculate the equation IL of t equals 1 over L, the integral from 0 to t VL of t dt plus I L of 0. What is I L of 0? I L of 0 is minus 200 milliamp. I L of 0 is what? Minus 200 milliamp. So the final expression is going to be I of L of t is 1 over 10 micro times the integral of 20 and then minus 200 milli, which is 0.2. Get it? 200 milli is what? 0.2. Correct? So what will be the expression? 1 over 10 micro times 20?
20 seconds? Or?
No, 1 over 10 micro times 20.
2 times 10 to the power
20
6.
to the power.
Are you sure?
20 to
Yeah,
the power
because
6.
0.
Well, this is 10. This is 10 to minus 5. This is 10 to plus 5. 10 to minus 5.
We can cancel the 0 of the 10 with the 20, so it will be 2 times 10 to the negative 6, to the power 6.
Yes.
So it will be 2 times 10 to the power 6 of t
Yes.
Yes.
Minus.
minus 0.2. So the question is, at what time it will be equal to 0.2 equals 2 times 10 to 6 of t minus 0.2. So 2 times 10 to 6 of t equals 0.4. So what is t? 0.4 over 2 times 10 to 6 seconds. What is the answer? 0.4 over 2 times 10 to the power 6?
It's 0.2, 10 to the power minus 6 seconds.
0.2
Yes.
times 10
To the power minus 6.
seconds. Right?
So it's not a x is
Give me the calculator, please. Well, 20 over 10 micro is 2 million. So 0.4 over 2 million is 0.2 microsecond. 0.2 microseconds. If I bring this in the quiz, can you solve it? Take a photo or watch YouTube, okay? Ready for your major? You studied for the quiz, خلاص. Okay. Today we will talk about a very important, a new chapter. Chapter what? 5. Chapter 4 we'll skip it. The transients we will skip it, okay? Today's chapter we will be talking about AC current and how to mathematically model it, how to properly deal with the math, okay? How to deal with its math. So, in this chapter, which is steady state, what does a steady state mean? Steady state is after some time when things settle down. After some time when things settle down and you see nice curves. There is no peaks. We will talk about phasors, sinusoidal currents and voltages. We'll talk about phasors. We'll talk about complex impedances. The impedance is another word of a resistor. So, resistance is for DC. Impedance is for EC. بالعربي resistance مقاومة. Impedance بالعربي معاوقة. يعيق. يقاوم يعيق. Okay? Get it? We'll talk about circuit analysis with phasors. What does phasors mean? What does a phase mean? تذكرون في الثانوي؟ الجيوب ساين وكوساين وتان موجات جيبية. So phasor is basically talking about the phase angle. The phase angle. Power and AC circuits, Thevenin and Norton with AC circuits. So forget about batteries now, and we will talk about what? Sinusoidal sources. Okay? Now, so far we only have studied analyzed circuits for constant voltage and current, major one. This chapter is for time variant sources, sinusoidal, yani everything has to be cosine or sine. We will learn how to get the current and the voltage for capacitors, resistors, and inductors. Based on that, we will deal with complex numbers. Do you remember what are the complex numbers? الأعداد المركبة. What are the complex numbers? You say, for example, you have a number which has 5 plus 2 times, well, you call it I. You remember? Math 001? In electrical engineering, we cannot use I, so they use 5 plus 2, they call it J. Why they use J? So that we don't confuse it with the current. Get it? In Math 001 it was what? Now it is, you have to live with it. If you type J in the calculator, it's like typing an I in the calculator. Get it? Is there a J in the calculator? I don't think so. But in MATLAB, there is a J. Please revise Appendix A. If you forget complex numbers, Appendix A of the textbook explains phasors. Mish'al. You have a major? Okay, why don't you go study and watch the YouTube later? It's up to you. What major is that? Machines? Machining, okay. So yeah, study. Please revise complex numbers, okay? Remember my rules, guys. If you can watch YouTube later. If you have something important, أنا ما راح أحكم. Don't take it personal. Why sinusoidal sources are important? What is inside this outlet? Sinusoidal. Okay? In electrical engineering, if you know this, you're ahead of half of the electrical engineers. Power plants, we generate electricity at almost 10 to 20 kilovolts. Then we have transformer that steps the voltage up to levels of 200 kilovolts. Not 5 volts, like major one, 200 kilovolts. Then we have transmission lines. Then we have another poles to go to distribution levels to 10 to 15 kilovolts, 15 kilovolts. And then it goes to your home to be 120 and 240 volts. Remember this. They will ask you in the interview. Generation, 10K, 10 to 20. Transmission, 100 to 200. Distribution, 15, 10 to 15. At home, 200 or 120. Get it? Sinusoidal signals, they are also used in communication. And if you remember Fourier analysis, did you study Fourier analysis? No. Okay. Fourier analysis is basically the study of sinusoidal signals. You study how perfect your sine is. If you have a sine that looks like that is perfect. If you have a distorted sine like that, this is not perfect. So Fourier analysis would tell you, basically, this sinusoidal signal is a sinusoid, but this one has what we call it harmonics. It's not part of the course, but in electrical engineering, in real life, you cannot have perfect sine. But in this course, we will have perfect sine. How to deal with it? Fourier analysis. Okay? Now, what is the height from 0 to Vm? It's the peak, right? One period is from peak to peak, which is capital T. Get it? Now, the whole 2 of the amplitude will be Vm, will be 2 Vm. Vm here minus Vm here. It will be what, ya Hatem? 2 Vm. We write a sinusoidal, in this course, we write it as what? Cosine. Do not write sines, okay? Stick with the cosine. Vm is the amplitude. Omega t. What is omega? Omega is the angular frequency. So omega equals 2 pi over the time period. Get it? From physics 102 or math 002. Which is equal to 2 pi times the frequency of the signal. What is the time period? The time period is the time from peak to peak. What is the frequency? Is how many peaks appear in 1 second. التردد. How many peaks appear in 1 second? What's the frequency of our electric system? Question, 50, 60, 70, 80? 60 hertz. You don't know? Check your iPhone charger. It says 550 to 60. It works with 50 or 60. What's the frequency in Bahrain?
50.
50. What's the frequency in Kuwait? 50. What's the frequency in the US? 60. What's the frequency in Japan? 50. Most of the world is 50. Except the US and economies built based on US standards, like Saudi. It's built on US standards, 60 hertz. Get it? In Riyadh, Jeddah, Khobar, all Saudi 60. Get it?
طيب شو الفرق بين 60 و 50؟ هل السيفتي فاكتور يفرق ولا؟
No, the only difference if you film the lights, it will illuminate differently. That's the only difference. 60 is more efficient. It's better. Okay?
So, البريود تي time ولا distance؟
Well, it's a time unit. It's a time. It has a unit of second. What's the unit of capital T? Seconds. What's the unit of 2 pi? Radians. What is the unit of frequency?
1 over c.
Hertz. 1 over T. 1 over second. What's the unit of 2 pi? Radians. What's the unit of omega? Radians per second. Sinusoidal signals, peak value, angular frequency. What is theta? Theta is the phase shift. Now, because this is a periodic signal, you can think of theta if and only if you impose it, you put another sinusoidal, and you measure the distance between this peak and the peak of the other sinusoidal. That is the phase shift between the two signals. It's like the voltage, you need a reference. So what is the phase shift of this peak? You can measure it with respect to the origin, or you can measure it with respect to another signal. So what is theta? Is the phase shift. What's the unit of theta? Radians. So theta has a unit of what? Radians. Get it? Again. What's the unit of amplitude? Volts. What's the unit of cosine? Unitless. The whole cosine is unitless. What's the unit of whatever inside the cosine? Omega, radian per second. Time, second. Second times radians per second is what? Radians. What's the unit of theta? In your calculators, always use radians. Radians. Okay? If you use degrees, you can use it, but make sure it says D or R in the calculator. Don't mix and match. Okay? Remember I told you the rule? Degrees for presentation. Radians for calculators. That's how I do it. But it's up to you. You can use degrees. What is your calculator setting?
Radians.
This calculator is in radians. It says big R. So stick with radians. You want to change it to calculator, go to mode, and then shift mode, and then you can 3 and 4. Shift mode 3 and 4. Do not mix and match. We do not mix and match radians and degrees. Okay? Sinusoidal signals are periodic. Periodic يعني دورية. يعني ما لها بداية ولا لها نهاية. The frequency is that the unit is hertz of the frequency. Okay, let's continue. Any question about this slide? For uniformity, we express sinusoidal function by using only cosines in this course. So if you have a sine, it has a minus 90 degree phase shift. Basically, if you write a sine and you draw a cosine, Something. That phase shift, it's not in seconds, it's pi over 2 radians. Get it? 002. Now we see how it is, why it's important. Get it? So, here's a simple example. You can write this as cosine by subtracting what?
90.
Minus 90. So it's cosine of whatever here minus 90. So it will be 10 cosine 200t minus 60. So we say the new phase angle is 60 degrees, minus 60 degrees. The previous phase angle is what? Plus 30 degrees. 30 minus minus 60 is what? 90. Get it? What's the phase angle of this sinusoidal signal?
30.
Plus 30. Don't say it, plus. What's the phase angle of this signal?
Negative.
The cosine. Minus 60, not negative, minus 60.
Because we changed from cosine to cosine.
Because we changed from sine to cosine.
So,
Yes.
function تروح لليمين ولا
What function?
الكوزاين.
It is the same. If you wanna, you can write cosine of z equals sine of z minus 90. The same.
لا أقصد لما تتحرك تروح لليمين ولا function.
We'll show it later. There's a visualization for that. But usually, if you make it minus, you move to the left. If you make it plus, you move to the right. Now, this is irrelevant because it's a periodic signal. Here is a question. Do you remember the formula P equal I square R?
Yes.
Now, if I have an AC signal, okay, the I is changing. What I should I sample? Should I pick this I? Should I pick that I? Should I pick this I? What should I pick? Well, the average is one of the things that's useless.
It's
It's not the average.
Yeah.
Summation.
What's the average of a sinusoidal signal? Zero. Half of it is above, half of it. Then you get a current zero, you get power zero, then. So average is not a good thing. We use root, mean, square. Root means root. Mean means average, the over n. Square is we square every sample. So we take samples from the current, I1, I2, I3, as much as possible, and then we calculate the root mean square. This RMS value, the root mean square, جذر مجموع جذر المعدل التربيعي. جذر root mean average divided by number of samples. N is number of samples. Square is we square every element. And we put it in the equation of the power. So from now on, in AC circuit, you always have to deal with the root mean square of the sinusoid. What is the root mean square of a sinusoid? Well, before we go that, we define the root mean square, which is the square root of number of samples, and then integration, don't be scared, it's just summation of the square sample values. For the current, the root mean square is the same. You take a square root, 1 over t, you integrate the number of samples, t is number of samples in that case, you take the integral of that square. Now this is not important. What's important is the equation of the power now, or Ohm's law, or anything. You really need to put RMS in the subscript. And now you have what we call the average power. It's no longer called an average, a power, it's average power. Pay attention with the subscript. Subscript average is different than without anything. Subscript RMS, root mean square. Okay? Is there a resistance sinusoid? No, it's a value, it's a constant. Get it? Is a C sinusoid, the capacitance? No. Is the inductance sinusoid? No, it's a constant. No, there is resistors along with capacitors, but it's not only a resistor circuit. We have circuits with R and C and L together.
دكتور الحين عشان نسوي الفانكشن الكونسمشن حق المقاومة لينير ولا
Irrelevant for now. We'll talk about it. For the resistor, it's I squared RMS times R. So it's is a number. يا شباب, the RMS value is a number. رجل 5, 5.3, 6.7. So if this is a number, this is a number, then the average power is number. So it has nothing to do with linear, but yeah, with the resistors it's linear. How to calculate it? For voltage, you just divide by, this is applied only to sinusoid. For voltage, divide the peak over square root of 2. Get it? Same for the current. For sinusoidal signal, the RMS value is, for the current, I RMS equals I M is max, over square root of 2, the same. This is only for sinusoidal signals. Get it? Get it?
Yes.
Like cosine.
Because this is how the math works. If you integrate this, we're not going to do it in the class, but if you integrate cosine square, do all the math, you will end up with 1 over square root of 2. But think about it. What is 1 over square root of 2?
It's 45 degrees.
No, has nothing to do with 45. What is square root of 2? 1.4, صح? So it's telling, no, yeah. What is 1 over 1.4? 7.
0.70.
So it's telling you, if you take a line of 0.7, which is 1 over square root of 2, this line gives you the effective value for power. يعني بدل ما تاخذ الافريج حقهم صفر، إذا أخذت 0.7 تعطيك نفس الباور. Get it? The math is hard. I'm not a math teacher. I don't care. I don't know how to do this integral. It's hard for me. The only thing I care about is you divide the peak by square root of 2. This is an example. Suppose the voltage is given by V of t 100 cosine of 100 pi of t. What's the unit of 100 pi? Radians per second. What is 100 pi? It is omega, صح?
Yes.
Applied to a 50 ohm resistor, sketch the voltage. Use MATLAB. I told you how to do it. If you sketch, what's the peak? 100. What is the time period? 2 pi over omega, which is 2 pi over 100 pi, which is
1 over 20.
1 over 20, which is
1
0.05 seconds. So the time period,
1 over
whatever, math is hard, what is the answer?
0.02.
0.02.
Is it 1 over 20?
No.
1 over 50.
Okay,
0.02.
1 over 50, which is 0.02 seconds. In milli, it's what? 20 milliseconds. Look at this figure. The distance between peak to peak is what? 20. Get it? So, what is the frequency? It's 1 over t, صح?
Yes.
Which is 20 hertz. Are you familiar with the symbol hertz?
Yes.
Skates.
refresh rate والجيمرز مش عارف ايش 420 هرتز و144. Well, why 144? It's twice the frequency of the supply plus a little bit of more margin. So you're beating the electricity.
So بس الفريكونسي مال التايم هنا per seconds not milliseconds.
Yeah, you're
We
right.
are dividing.
Megahertz, which is 1 over 20 times 10 to minus 3, which is, I don't know.
Could be kilohertz.
No, what's the, yeah, you're right. I need calculator. Give me calculator. I need a calculator with me all the time. 1 over 20 milli, which is 50 hertz. 50 hertz. Get it? It's 50 hertz. Okay? This is in Bahrain, okay? So this supply probably was taken from a 50 hertz country. Now what is the root mean square of the voltage? What is VRMS? 100 divided by square root of 2, which is 70.71. What is the power? The average power? VRMS square divided by R, which is 70.71 square divided by 50. What's the answer?
99.99.
100 watt. If you want to use the real-time power, it will be the voltage, the actual voltage without taking the average, which is 100 square cosine square 100 pi of t divided by 50, which is a time expression. So the power changes in time, and that's the plot of it. Okay? Keep in mind that the frequency with cosine square is different function than cosine. So if you notice here, the power actually shrinks. The time period shrinks of the power. Get it? What I want you to learn is how to find omega, how to find F, how to find T, how to find RMS, how to find the average power. That's the most important thing in this example. Another question. No one got full mark. Average is 62.5.
No
But-
in this section or no?
Oh no. No one got full mark. Maximum was 17. It's weird.
Not.
I told you.
maximum كم؟
17 out of 18.
Our section.
I don't know. Don't worry about it. Worry about this. Now this question is I'm not really excited about, but what if I have a non-sinusoidal voltage? For example, what if I have a triangle function? Then you really need to apply these formula. So for example, from 0 to 1 we have the line t, 3t, and then you square it. It will be 9t squared. And you have this line which is 6 minus 3t, and then you square it. And you take 1 over capital T, you square over 1 triangle, 1 over 2, you do the integral. If you do the integral, the exercises for checkpoints, you will, okay, why it's not clear? It's not clear. We'll skip it for now. Okay?
Does the triangular voltage exist?
Not in real life. What are you talking about? About what major? That major? Yeah, I told you. Not sure about the statistics. Maybe it needs to be revised, but this is initial. Dr. Atiyah said the average is 62.6 for all sections. What did I predict? Who was here before I predict the exam? Who was here? What was my prediction? What is 11?
It is 11 points. Yeah.
So was my prediction correct? Okay. Don't worry, ya shabab. 60 is okay. Okay? Don't worry about the grades. Yeah. That's okay. Remember, I'm not the only instructor for this course. Well, this slide is not clear. I will fix it later. You cannot read it, صح? Can you read it?
Yeah, but
Find the angle.
Okay, find the angular frequency. What's the angular frequency? 200 pi.
Yeah.
What's the frequency in hertz? 200 pi over 2 pi, which is 100 hertz.
The period.
What is the period? 1 over 100, which is 0.1 seconds. What is the peak? 150. What is the RMS? VRMS?
50 over.
100 over 50 over square root of 2. You do the math, which is 106.1. Okay? And then find the first value of T max, etc. This is you really need to plot it. I'm not going to solve it. Another function, change the sign to cosine. It will be 100 sine 350 plus 60 minus 90. It will be minus 30. What's the phase shift of the sine signal? 60.
60.
60 plus 60 degrees. What's the phase shift of the cosine signal? Minus 30 degrees. Suppose that the AC line voltage powering your computer has RMS value of 110, frequency 60 Hertz. The peak voltage is attained at time 5 milliseconds. Write an expression for this AC voltage as a function of time. So if I tell you the peak voltage is attained at 5 milliseconds, what does that mean? It's AC signal, volt, AC line, powering computer. Okay. What is omega?
2 pi.
2 pi times F, which is 2 pi times 60, which is 120 pi. What is 120 pi? 377. So it is cosine of 370. What's the peak?
110 times square root.
110 times square root of 2, which is 155.6 volts peak. Okay? It is a cosine. Cosine of 0 is the max. Okay? But he's telling you it reaches the max at 5 milliseconds. How to convert 5 milliseconds to degrees?
Multiply by 180 divided by 5.
Well, you can think of it as that way. Okay, time is up. You can leave. We'll continue this exercise next lecture. Any question?